Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week. And we're going to take a deeper dive into what happened with Hurricane Otis, which went virtually unnoticed last week, but it was a historically unprecedented event. And it's worth noting here what happened and what this tells us about our climate and how it is changing and the risks that we are undertaking as a result of what we're doing. So let's go on ahead here and take a look, first of all, at a post-mortem, if you will, of Otis. Now this is the IR imagery, the infrared imagery, where you're taking a look at the cloud top temperatures. When you see the reds and then the blacks and even the grays there in the middle, those are very cold clouds, which means that they have to extend very high up into the atmosphere. And as I put this into motion, you will see a very, very well-defined eye form. And the reason the infrared imagery is so good at that is that in the eye, there are very few clouds. So the satellite is sensing the temperature of whatever it bumps into first. If it bumps into very high clouds, then it's going to measure a very cold temperature. But if it isn't seeing any high level clouds and it is able to look all the way down to the ocean, which obviously is much warmer, then it's going to show up as a much different temperature. And so the eye ends up being very well defined in the imagery. So you can see that happen here as we again put this loop into motion. There's the eye forming right there, very, very well defined. The system really doesn't move a whole lot for a while, but then starts to make a move toward the Mexican coast and makes landfall around Acapulco, and then of course weakens once it moves inland and loses its source of energy, which is the warm ocean. And the ocean water temperatures along the Mexican coast where the storm made landfall were around 88 degrees Fahrenheit. Now, usually 80 degrees is the minimum threshold for a tropical cyclone to get going. So obviously 88 is well above that. So these were the maximum observed sustained winds with Hurricane Otis starting at 8 a.m. on October 22nd. And you can see that initially it really didn't intensify much or at all for some of those time steps. But then beginning about 8 a.m. on October 24th, all of a sudden it just absolutely exploded. And by the time we got to 2 a.m. on the 25th, the maximum sustained winds were 145 knots, which translates to 167 miles per hour. And then, of course, once it made landfall, then the wind speeds dropped off very, very rapidly. Now, we are in an El Nino, and that will become official in about a week when we have the data come in from the month of October. You have to have, we've talked about this before, you have the Oceanic Nino Index, which has to be 0.5 or higher for 5 consecutive 3-month overlapping periods. So let's say it started in June, July, and August. So if that value is 0.5 or higher, and then you have July, August, September, August, September, October, September, October, November, and October, November, December. This is a hypothetical example. If all 5 of those 3-month periods consecutively are above 0.5, then you have an El Nino. And of course, El Ninos are associated with very warm water temperatures in the eastern Pacific because the trade winds are weaker, and so it allows warm water to come eastward from the western Pacific toward the coast of South America and Central America. So it's no surprise that the water temperatures are unusually warm in that part of the world, and of course that helped to fuel Otis to a great degree. Now, the experts at the Hurricane Center thought that there were some other mitigating factors that would prevent it from exploding like it did. Obviously, that did not turn out to be the case, and that is not a criticism of the National Hurricane Center. It's just that these rapidly intensifying tropical cyclones are very difficult to forecast. There's a threshold that has to be met, and it's almost like having a ball at the top of a hill. That it's got all sorts of potential, but as long as nobody moves it, it doesn't go anywhere. But if you give it a little nudge and it's able to get over the top of that hill and roll down to the bottom of the next valley, then all of a sudden it's never coming back to where it was. And that's exactly what happened with Otis. So these are 12-hour forecasts from the Hurricane Center. The dates on the left are the times that the forecasts were issued and then what actually happened. So you can see that all the way up through 8 p.m. on the 23rd of October, the errors were either non-existent or very, very small. But then all of a sudden, when you got up to October 24th at 8 o'clock, this is a 12-hour forecast, folks. The error was 55 knots. It was forecast to be 70 knots. It verified at 125. It gets worse. These are 24-hour forecasts, and for two different time steps, it was under forecast by 70 knots, which is over 80 miles per hour. For the 36-hour forecast, it was under forecast by 85 knots, which is about 100 miles per hour. And for the 48-hour forecast, the error maximized at 95 knots, okay? Almost 100 knots, or I think that's about 115 miles per hour, okay? These are huge errors over a very, very short time period, okay? So obviously something was going on here that is beyond the scope of our science right now to be able to diagnose and accurately predict. Now, rapid intensification is defined, there is an official definition for this, of an increase in the sustained winds of 30 knots or more during a 24-hour period. So you can see that we were under that threshold through October 24th at 8 o'clock, but then the 24 hours ending at 2 p.m., the wind speeds increased 55 knots. By 8 p.m., the 24-hour change was 80 knots, and by 2 a.m., the increase was 95 knots. The minimum threshold is 30. Gee, do you think we qualify there? That's pretty amazing. And again, historically unprecedented in terms of recorded history. And I know people are going to say, oh yeah, but we don't know what's happened all the way back to the beginning of the earth. Yeah, you're right, you know, but we've got a pretty substantial database there. And when you see something like this happen that nothing else comes close to over that entire period of time, there's something there, okay? There is something there. All right, so here are some comments. Undoubtedly, this will ruffle some feathers, but I don't get paid not to ruffle feathers, okay? So, scientists predicted many years ago that with a warming climate, there would be a much higher probability of rapidly intensifying tropical cyclones. In the Atlantic Basin this year, we had Idalia, which made landfall along the Florida coast, and we had Lee. Thankfully, it stayed out in the ocean, but it also went through a rapid intensification process. And we're seeing more and more of this as we head through time. Rapidly intensifying tropical cyclones are extremely difficult to predict. No better case in point than what happened with Otis last week. Now, ideology-driven opinions about science issues are not valid, period. End of discussion, okay? And I know this to be true because you know what? I did that for 30 years, okay? Much to my chagrin, much to my embarrassment, okay? When you're dealing with a science issue, you deal with observations, okay? You deal with measurements. You don't deal with opinions. You don't deal with the injection of political ideologies put forth by cable news channels or talk radio or social media. These people are not scientists. They will try to cherry pick anything they can to make their argument. And it's like a game of whack-a-mole. You knock one down, another one pops up. You knock that one down, another one pops up over here. It gets to the point, ladies and gentlemen, where it isn't worth the effort to play the game of whack-a-mole anymore, okay? This is the best science that we have. If somebody comes up with something better and we find out down the road that we were totally wrong about this, that's great. That would be great news, wouldn't it? Okay? But we're not there at this point. The best science we have in this entire world is only pointing in one direction. Scientists have gone to painstaking measures to find other reasons for the observed warming that we have seen. Up to now, there is no plausible explanation other than the emission of greenhouse gases by human beings. There are some people that will tell you, oh, it's the sun. We have satellites that measure the amount of incoming solar radiation at the edge of the Earth's atmosphere, and there has been no statistically significant change for decades, okay? So that is not a valid argument. If somebody tries to lay that on you, then tell them that they need to check their sources. Now, we are playing with fire here, okay? And I am not one that tends to be overly dramatic, but we are. Now, we need to work together. Isn't that a novel idea, okay? Instead of this my team, your team approach, What do you think of the idea of us all acting like we're Americans and we're in this together, okay? And there are such things as low probability, high impact events. You may not think the chance of catastrophic climate change is high, but if it occurs, there is no going back. It's like the ball at the top of the hill rolling down into the next valley, okay? So we need to work together. Yes, that's a unique word, isn't it? Together. To find ways to minimize the risks associated with what we are doing right now, okay? Now, again, if something comes along that totally disproves all of this science, hallelujah, okay? But nothing has come along yet, and there is no indication at this point that anything is going to come along to disprove this. This is the best scientific explanation that we have at this point. So again, let's put aside the political differences and let's work together as Americans to figure out a way to minimize the risk and hopefully not go down a road that we can't recover from. All right, folks, that is bonus weather video for this Tuesday. We'll have another one tomorrow and another one on Friday. Hope you'll join me for both of those entities and, of course, the next daily weather update coming up tomorrow. So stay warm, and we'll talk to you again late afternoon tomorrow. Take care, everybody. See you later.